here we go. We are simplifying this. The reason that we know that we're simplifying, although on your test or quiz it will say simplify, but the reason that we are not solving is because we do not have an equal sign. So we cannot solve for a value of x because we do not have an equal sign. So what we have to do here is we have to create two new rationals that have the same denominator. So this right here, I have x minus 1. That is going to be part of my least common denominator. Then I have 2x minus 3, and that is also going to be part of my least common denominator. Now, the other thing that I want to deal with first, can you shut the door for me, Mark?
Oh,
thank you.
Sorry.
No, you're fine. Is this minus sign. I want to change that minus sign to a plus, and who am I going to give it to? The 3, yes. So I want to move that to the numerator so that I can distribute when necessary and I don't lose it, okay? Negatives are something that we lose all the time, okay? And we don't want to do that. So now I've got 5 over x minus 1, okay? What is this missing? So I've got x minus 1 accounted for. What do I not have in this particular one?
The 2x minus 3.
Excellent. So I've got 2x minus 3. If I multiply the bottom times 2x minus 3, what do I have to do to the top?
2x minus 3, multiply it.
Okay.
To the 5.
Good.
Sorry.
You're fine. I have to do both. I have to multiply both by that. Now, I've got plus negative 3 over 2x minus 3. So for this one, I've got 2x minus 3 accounted for, but I'm missing the x minus 1. So it's the x minus 1 that I'm going to multiply times the top and the bottom. So my new denominator is x minus 1 times 2x minus 3. You can multiply that out if you want to, but I will tell you that most students don't. Most students do not multiply that out. So I guess technically it would be more simplified if you multiplied it out. I'm trying to think back into classes that I actually took where that was necessary and it just wasn't. So that's a good question. I just don't have a great answer for it. Okay. So now we're going to distribute the 5 to both of these. So 5 times 2x is 10x. 5 times negative 3 is negative 15. Okay. Now I'm going to distribute my negative 3. Negative 3 times x is minus 3x. Negative 3 times negative 1, positive 3. Okay, now I've got some like terms that I can simplify or combine. 10x minus 3x is 7x. Negative 5 and positive 3 is negative 12. Good job. So this is my final answer right here. Cool. Okay, we ready to do another one? Okay, I'll give you 3 minutes. You don't have to.
Don't have to? I'm just asking.
Some students do it just to kind of help them keep everything straight, but you don't have to.
bless you. Is there pollen in the air or something?
I don't know. There is a type of allergy and pollen that you can get in the fall. I don't know the answer to that, but I think it's a good assumption. It's a reasonable assumption.
Yeah, because everyone's sneezing. I've sneezed twice today.
Sometimes the 2 on this one confuses students, but we can write that as 2 over 1. 2 over 1. So anytime you do not have a denominator written, that denominator is over 1. We do not need to write down the 1 as part of our LCD because 1 times any number or any expression is just going to be that expression. So 3x minus 1 is the only part of our LCD. It's 3x minus 1. So I've got 2 over 1, and I need to multiply that 1 times 3x minus 1. And if I put it in the bottom, I also have to put it in the top. Okay? Now, my second rational, 4x over 3x minus 1. That one, I don't have to multiply anything times that one because it's already in terms of my least common denominator. So my new denominator is going to be 3x minus 1. I'm going to distribute this 2 right here. 2 times 3x is 6x. 2 times negative 1 is negative 2. And then I am going to add that to our 4x, and that is all over our 3x minus 1. So now I have 6x and 4x. That gives me 10x minus 2 over 3x minus 1. You can't because it's in the denominator. So your denominator is going to stay separate from your numerator. But that's a good question. And you also have to think of that 3x minus 1 as a binomial unit. So you can't break that up because it's a binomial. It's a good question. Okay. Another simplifying. And this simplifying sometimes gives students some fits. I want you to break down each denominator, okay? Write out each denominator so that you can see what each denominator is made up of. So for the first one, I want you to have 7 over 3 times x times x. I want you to break the 4 down also. And then that'll help you decide what you need in the LCD. Okay, so I am going to break down each one of my denominators. The other thing that I want to deal with is I want to deal with this minus sign. So I'm going to deal with the denominators and the minus sign in this step right here. So my first one is I have 7 over 3 times x times x. Okay, and I write it out like that so that I can make sure both of those x's show up in my LCD. Then I am going to have plus negative 9. So I have moved that minus sign to my numerator. So I've changed it to plus and then made the second one its opposite. Okay, that's going to make sure that I don't lose my negative. 4x breaks down to 2 times 2 times x. Okay? Then I am going to change my minus to a plus, and I'm going to make my 5 negative. The 2x doesn't break down to anything. We just leave it as 2 times x. Now what I have to do is I have to make sure that every piece of this is included in my least common denominator. So for my first one, I've got to write down a 3, an x, and an x. So I'm going to have 3 times x times x. Okay? Now, for my second denominator, this x is already taken care of because I've got it over there. Do I have a 2 yet?
No.
No. And do I have a second 2?
No.
So I need to write both of those down. Okay? For my third denominator, I've got a 2, but I've already got one accounted for in my LCD, and then I have an x, and I already have that accounted for in my LCD. Now, some students at this point like to think of their LCD as 12x squared. That's okay. I prefer that you leave it broken down because then you are sure you don't forget anything. Okay. So my first one is 7 over 3 times x times x. I have a 3, I have an x, and I have an x. What's missing?
That's 2 2s.
2 times 2.
2 2s.
The 2 2's. So I have 2 times 2. If I do it in the bottom, I have to do it in the top. Okay? Now, for my second one, I have 2 times 2 times x. So I have a 2 accounted for, a 2 accounted for, and an x accounted for. I'm missing a 3 and a second x. If I do it in the bottom, I have to also do it in the top. My third, I have negative 5 over 2 times x. I have a 2 accounted for, and I have an x accounted for. What am I missing? 3 and 2. A 2, a 3, and a x. Good. What happens when you write it out as 12x squared, students don't always get the variables that are part of that least common denominator. That's what they lose. They almost always get the numbers correct, but they don't get the variables correct. That's why I encourage you to leave it written out like that. Okay, so now I have a denominator of 12x squared. That's our common denominator. 7 times 2 times 2.
28.
Okay, so then I have 28. Negative 9 times 3 is negative 27. And then that's times x. So I have minus 27x. My last one, I've got things kind of all over the place here. Oh, no, I don't. I'm sorry. Negative 2 times positive 2 times positive 3.
Negative 30.
Negative 30. And that is over x. Okay? Now, what's negative 27 minus 30x?
Negative 57x.
Okay, so my final answer here is going to be 28 minus 57x over 12x squared.
Is it okay if we have it still broken down as the
Yes.
denominator?
Yes, so the question is it okay if you still have it broken down like this in the denominator? And the answer to that is yes, it is okay. Okay. Is it okay if I go off this screen? Okay. We are going into equations now. So you are going to solve this equation. You are still looking for the LCD. You're still looking for the LCD, but you're going to multiply everything by the LCD this time. Okay, so you are finding common denominators, and what you want to do is you want to multiply everything by this instead, because you want to get rid of the denominators, is what you're doing there.
Oh, so.
Because we've got the equal sign, so you want to get rid of the denominators by canceling them out.
Okay. So also put the LCD on the top.
Mm-hmm.
And don't put the n times 3 on the bottom, just leave it the same.
Right. what we want to do when we've got when we've got a problem like this, when we've got the equal sign, is we want to eliminate our denominator. We want to get rid of that. And the way that we get rid of it is by multiplying everything by the LCD. So again, we're going to ask ourselves, can I break down or factor my denominator in any way? Okay? And I can't. I've got n and I've got 3. Okay? So my LCD is 3n. I do not have to include the n twice. Okay? Because here I write it down for this. Then I write down the 3. This n is already accounted for. So you don't have to do n squared. The only time you would have to do n squared is if I had n times n in the same denominator. And sometimes that does confuse students a little bit, and so I'm happy to talk about that more if you want me to. Okay, so what I'm going to do now is I'm going to multiply everything times 3n over 1. So I have 5 over n times 3n over 1. Then I am adding that to 1 over 3 times 3n over 1. And that's equal to 7 over n, times 3n over 1. Okay? If it's on the top and the bottom, I can cancel it. So I have n and n, so I'm left with 15. 3 and 3 cancels, so I'm left with n. Then I have an n and n, and I have 7 times 3, which is 21. Okay? My next step is to subtract 15, and I get n equals 6. Now, we didn't talk about the undefined value, but I do have to worry about undefined values anytime I have a variable in the denominator. So, what value for n would make my denominator 0?
-6.
Okay, -6. If I plug -6 in for n right here, I would get 5 over -6, which is okay. If I plugged -6 in for n right here, I would get 7 over -6. So what I have to worry about is I have to worry about a value that I plug in for n. So it's my denominators that can't equal 0. And the only thing I have in two of those denominators is an n. So the value that n can't be is 0. Because if I plugged 0 in for n, here I would get 5 over 0, and that's not allowed. What would I get right here if I plugged 0 in for n? I would get 7 over what? 0. Okay, and that's not allowed. So my undefined value is 0. So is n equals 6 okay? Yes. Okay? Here we go. I'm going to give you guys another one. You're multiplying by the least common denominator.
You have to count twice, right?
Nope. You don't have to count it twice. negative 56.
Thank you.
You're welcome.
Can it be a fraction?
It can be.
And a negative over a negative is a positive.
Correct.
We always have to find the undefined value.
If there is a variable in the denominator, I want you to get in the habit of finding the undefined values.
Well, I mean on the test. Exactly.
There could be an undefined value that's part of your answer on the test, so you're going to want to do that. Let's find the undefined values.
Hey, boy.
So, okay, let's try this one. What is my 2 over? What can I write that 2 over? Good. I'm going to write it over 1. So I'm going to go ahead and do that. I've already kind of got that minus with the 3x, but I just want to be super clear that that belongs to that numerator now. So I changed my minus to plus and put the negative with my numerator right there. So if I have to distribute that 3x, that negative goes with it. Now, for this first one, I can write down the 1, but I don't have to, okay? Because 1 times any quantity is going to give me that quantity. Then I'm going to have x minus 4, and then I'm going to have x plus 7. Okay, so that's going to be my LCD. Now, I want to look at undefined values. Do I have to worry about undefined values here? Do I have to worry about an undefined value when my denominator is 1? Is there a variable in this denominator? No. That denominator is 1, so I don't have to worry about an undefined value. Here, is there a number that I could plug in for x that would give me 0 right here? Positive 4. Okay, so x cannot be positive 4. And the reason for that is because x minus 4 can't be 0, so x can't be positive 4. Excellent job. Okay, so we're going to use that same idea and we're going to decide what x can't be for my third rational. So x plus 7 can't be what? Can't be 0. So what can x not be? Excellent. So my undefined values are 4 and negative 7. So if I got 4 or negative 7 for my answer, I have to throw them out. I can't have it. It makes it undefined. Okay, now what I'm going to do is I'm going to multiply everything times my LCD, which is x minus 4 over x plus 7. Okay?
If the LCD is doubled for 2, do we just put 2 on each one? No, I mean the LCD and the 2, do we just multiply 2 to each of the LCD?
Well, you're going to FOIL first. We're not there yet. Wait until I get there, okay? So then I've got x plus 7 over 1. Okay? Now I've got plus negative 3x over x minus 4. And so I'm going to multiply this times x minus 4 over x minus 4 times x plus 7 over 1. And that is going to equal 14 over x plus 7 times x minus 4 and x plus 7. Okay, now I'm going to start simplifying. So I do not have anything that I can cancel out in my first term or my first rational expression. So I'm keeping everything. So I'm going to have 2 times x minus 4 times x plus 7. Okay, and Mark, I think this is what you were talking about. So the way that you would do this is you would FOIL first, then distribute the 2. That's how I would do that. Okay, my next one, I've got minus 3x. I am going to mark out my x minus 4. And then I'm going to have the minus 3x is going to be times x plus 7. What do I have to distribute to the x plus 7?
Negative 3x.
Excellent. Negative 3x. Great job, Hannah. Okay, then I've got 14 over x plus 7. So I'm going to mark out my x plus 7s. And I'm left with 14 times x minus 4. Okay. Now, my first one that I need to simplify right here, I'm going to go ahead and FOIL that first. So I've got x minus 4 times x plus 7. X times x is x squared. X times 7 is 7x. Negative 4 times x is negative 4x. Negative 4 times 7 is negative 28. Then I've got x squared plus 3x minus 28. What do I now have to multiply that by? 2. Okay, so I multiplied these 2 together. Now I've got to multiply the 2. So I've got that 2 right there. So now I have 2x squared plus 6x minus 56. Okay, so we had a lot of multiplying to do there. So I have 2x squared plus 6x minus 56. Now, for my second expression, negative 3x times x plus 7, I'm going to distribute negative 3x. So I have negative 3x times x. That's going to give me minus 3x squared. Negative 3x times 7 is going to give me minus 21x. Then on the right-hand side, I have 14 times x. And I have 14 times negative 4. 14 times negative 4 is going to be negative 56. Now this looks a little bit ugly, but it's going to clean up nicely. Okay? The first thing that I'm going to do is I'm going to combine whatever like terms I can on the left-hand side. So I have positive 2x squared and negative 3x squared.
Negative x squared.
That leaves me with negative x squared. You're correct. Thank you. Okay. Then I have positive 6x and negative 21x. That leaves me with 15. Negative 15x. Okay. Then I'm left with negative 56. Okay, now what I'm going to do is I'm going to add 56 to both sides. When I add 56 to both sides, they cancel. So they're gone. What else do I need to do?
Subtract 14x to both sides.
So now I'm going to subtract 14x to both sides. And I am left with negative x squared minus 29x is equal to what?
0.
Okay, now that looks messy. Can I divide everything by negative 1?
No. Oh, well, yeah, you could.
I could. I'm going to. Okay? If I divide everything by -1, that gives me a positive x squared. And a positive x squared is easier to deal with. Okay? So now I have positive x squared plus 29x equals 0. What is common to x squared and 29x? X. Good. I heard x. So I have x times x plus 29. So x is 0 and x plus 29 is 0. So my answers are 0 and what?
-29.
Excellent. Okay, and I know I erased my undefined values. Were 0 or -29 part of my undefined values?
No.
No. So I'm good. So these are my answers. Okay? Okay. Okay, I'm going to do the last one just for the sake of time. So you certainly can do it with me, but just so that we can be sure to get through it, I'm going to go ahead and do it. We'll do it together. So the first thing I'm going to ask is, can I break down these anymore? Can they be factored at all? And the answer is they cannot. They cannot be factored at all. Okay? So my first part of my LCD is going to be the n plus 1. Okay? Here I've got a positive 2, so I've got to put that in my LCD. Then I've got n plus 2. Now I want to ask you a question. Is the 2 that's right here different than the 2 that's right there? Yes. Tell me why, because you're absolutely correct. Can you tell me why? Good. You are absolutely correct. That is 100% correct. The 2 is standalone. That 2 is all by itself. That n plus 2 cannot be separated. It's all together or it's nothing. Excellent job. Good job. Okay, so here is my LCD. Now what I want to know are my undefined values. My undefined values. Okay, what makes this undefined? What number do I plug in for n to make this part of the fraction undefined? Good. So n cannot be -1. And if you can't look at that and see it, then what you do is you set your denominator equal to 0 and solve. That's how you get the n can't be -1. Okay? So what can n not be here? Excellent. Excellent. Okay, so now what I'm going to do is I am going to multiply everything times my LCD. So I have n plus 1, n plus 2, and then I have another 2 in there. I'm sorry, that's hard to read. I write too big. I know I write too big. I cannot write smaller. Even when I tell myself to write smaller. Okay, so now we're going to multiply everything by the LCD. So I have n over n plus 1, and I am multiplying that times n plus 1 times n plus 2 times 2. Then I have 1/2 times n plus 1, n plus 2 times 2. Okay, I'm going to erase my undefined values, but you guys keep a note. Make note of them. Make sure you got them. Equals -2 over n plus 2 times n plus 1 times n plus 2 times 2. Okay? So my first one, n plus 1 and n plus 1. Now, what do I have to distribute to n plus 2? So here's my n plus 2. What's left? A 2 and what else? Good. Okay, so I've got to distribute the 2 and the n. So that looks like this, 2n times n plus 2. Sometimes students miss one of those. Good job. Then my next one, I mark out my 2's. So I'm left with n plus 1 times n plus 2. What am I going to have to do with that? What am I going to have to do with n plus 1 times n plus 2? FOIL. Excellent. Then I have n plus 2 and n plus 2. I'm left with negative 2 and positive 2. What's negative 2 times positive 2? Negative 4. And then I've got n plus 1. Okay. So now, 2n times n is 2n squared. 2n times 2 is 4n. I need to FOIL n plus 1 times n plus 2. So I'm going to do that off to the side. N plus 1, n plus 2. N times n is n squared. N times 2 is 2n. 1 times n is 1n. 1 times 2, 2. So I have n squared plus 3n plus 2. Okay, so I am replacing this right here. That's what I'm replacing. So n squared plus 3n minus 2 equals negative 4n minus 4. Now, I'm going to focus on the left-hand side first. I'm going to focus on that first. I have 2n squared and I have n squared. That gives me 3n squared. Then I have 4n and 3n. That gives me, it's 7n, right? 7n. Okay, then I'm left with minus 2. Okay. The first thing that I'm going to do is I'm going to add 4 to both sides.
It would be a plus 2 instead.
Okay, so then I have 3n squared plus 7n plus 2 equals negative 4n. Okay, I've got to get it set equal to 0. The reason that I have to get it set equal to 0 is because I'm dealing with a quadratic. I know I'm dealing with a quadratic because I have a variable squared. So now I do plus 4n. Okay, so I have 3n squared plus 11n plus 2. Did I make a mistake somewhere? Oh, no, maybe not. Yep, I must have. Oh, I think my 2 is supposed to be positive. Yep, that's where my mistake is. Okay, so this 2 is supposed to be positive. I apologize about that. Okay. Okay, so when I FOIL, 1 times 2 is positive 2. That's where that positive 2 comes from. Okay, now I've got something I can work with. I have 3n squared plus 11n plus 6 equals 0. I have to factor this. This isn't going to go away. These are the factorings that don't go away. I have to do 3 times 6. What's 3 times 6?
18.
18. So my product
It would be n plus 9 and n plus 2.
is 18. You're correct.
Sorry. Yeah.
My sum is positive 11. What two numbers multiplied together give me 18, added together give me positive 11?
N plus 9 and n plus 2.
That is correct, but you're not, because we have an a value in front of that n squared, we have to split the 11. That's what we have to do right here, is split this 11. So it becomes 3n squared plus 9n plus 2n. Okay? 3n comes out of the first set, so I'm left with n plus 3. Okay, 2 comes out of the second, so I'm left with n plus 3. So I have 3n plus 2, n plus 3. So 3n plus 2 equals 0, n plus 3 equals 0.
N equals negative 2 over 3 and negative 3. I'm sorry, I can't help.
Okay, so n plus 3 equals 0. So I get n equals negative 3. 3n plus 2 equals 0. I subtract 2 from both sides. Then I divide by 3. So n can be negative 2 over 3, or n can be negative 3. Are either one of those values undefined? Are either one of those values undefined? No, neither are undefined, so both of those are our answer. Okay? Practice, practice, practice.